Alright, good day students. In this clip, we're going to be going over how to graph complex numbers in both rectangle and polar form, and then we'll learn how to convert between complex numbers in polar and rectangular forms in the second part of the notes. So let's write down the title for the first part of the notes. Notes 1. For notes 1, the title is basically graphing complex numbers. Okay, in complex numbers. All right, we're going to take a look at two examples before we start the first part of the classwork. The first example is as follows. It involves rectangular forms. It says graph and find the absolute value of the given complex number. Okay? And the number we're dealing with here, example 1, is z equals -2 minus 5i. Okay, the standard way of writing complex numbers is z equals to some number. Okay, so we're going to attempt to graph this, and then we'll find the absolute value. Okay, so to graph this, we have the real part and the imaginary part. Okay, the real part is like the x, and the imaginary part is like the y. The real part is like the a, and the imaginary part is the b. So standard notation, a is the real part, which is -2. Okay, it's technically the x-axis. This is like the x-axis. Okay, technically. And then the second one, the b, is -5. Notice I didn't take the I. You just take the number, the coefficient of the imaginary part. Okay, so this is the A. The one that comes first is x, and the one that comes next is second. Alright? So let's just add some additional detail to it. This is the same thing as the x coordinate, and it's also the same thing as the real part. Okay? That R I wrote there, that's the standard notation for real numbers. So this is the same as the real part. This is the same thing as the y, and is also known as the imaginary part. Okay? Now let's go ahead and graph it. It's just a coordinate x, y. We're going to be graphing the coordinates. We're going to graph the coordinate -2, -5. Okay? That's all we're doing in this problem for the first part. Okay? So let's create a coordinate system. There goes my imaginary axis. There goes my real axis. We're going to be in quadrant 3 since we're going left and down. Alright? So let's label our axis. This is the real R, which is also the x. And this is the imaginary axis. Okay? Okay. I made a mistake. We're supposed to use lowercase. Let's be standard here. Alright, lowercase I. That's how you write. Okay? Alright, so let's graph it. So we're going to go 2 to the left. 1, 2. That's -2, and then we're going to go 5 units down for the y, or the imaginary part. 1, 2, 3, 4, 5. And there goes your, there goes z. Okay? So there you have, that's the graph. Now you have to find the absolute value. The absolute value is also known as the r. Okay? The absolute value is basically this length right here. This is what the absolute value is right there, that length. Okay? That is known as r, which is basically equal to the absolute value of z. Alright? If you notice, if we draw this completely, we have a right triangle. Okay? How do you find the hypotenuse of a right triangle? We use the Pythagorean Theorem, right? Because this is the A and this is B. So we're going to use a formula. I think you already know this formula. Absolute value of z equals square root of a squared plus b squared. Remember, this is c squared, right? But if you read both sides, you end up with this. and is also the same thing as what we used before, the square root of x squared plus y squared. Okay, remember that let's see, a is the same thing as x and b is the same thing as y. All right, so that's what we're going to do here. We know what a and b are, or x and y. We're going to plug it into this formula, and that tells us what the absolute value is. All right, so let's go ahead and do it. So we're going to have the absolute value equals the square root of -2 squared plus -5 squared. Okay? Alright, now we're just going to use the properties of the order of operations to simplify, move this thing out of the way, to simplify this problem. Okay, so to do this, this is going to become the square root of 4 plus 25. And then if you add those two together, you're going to have the square root of 29. This cannot be reduced any further, so the absolute value of z is equal to square root of 29. What does that mean? It means that this length right here from the origin to the point is root 29. Alright? We're going to find approximate value is slightly over 5. You can do that with your calculator, but this is sufficient for me. Okay? Alright. Now let's try another example. How about if the problem was presented to us in polar form and we're supposed to graph it on the polar coordinate system? Number 2. Let's say we're supposed to graph 4 cosine 11 pi over 6 plus I sine 11 pi over 6. Okay? So all you need here is r and theta. These two are thetas. They're always the same, and r is always the number that comes first. This is a complex number in polar form. How do I know it's polar? Because angles involve rotation. Okay? Anytime you have sine and cosine, it involves angle. The argument of sine and cosine are angles. So anytime you see sine and cosine, know that you're spinning. Okay? X coordinate is cosine, y coordinate is sine. Alright? So to graph this, I need the coordinates r and theta. So I can put it on this nice polar grid I have right here. Okay? So let's see. What is r and what is theta? R is simply the number in the parentheses right here, number in front of the parentheses, and this is theta and this is theta. They're always the same. Okay, these two basically are theta. So what are we gonna graph? We're trying to graph the point r, which is 4, and theta, which is 11 pi. Oh gosh, 11 pi over 6. Okay, 11 pi over 6. That's what we're trying to graph. Alright, so let's go ahead and graph it. Let's go on a coordinate grid. 4 is 1, 2, 3, 4, and 11 power 6 go right, bam, right there. That goes our point. Okay, so there you have it. That's how you graph. That's how you graph complex numbers in polar form. All right. Okay, now we're gonna go ahead and start the first part of the classwork, and then we'll be back to do some more notes on conversion. Alright, welcome back, students. Now we're going to do the second part of the notes, which is converting complex numbers between polar and rectangular form. So write down the title for the second part of the notes. That's 2. Converting complex numbers. Converting complex numbers between polar and rectangular forms. Polar and rectangular forms. Okay? There goes the title. First thing we're gonna do, let's do the more challenging one first. We're gonna do conversion from rectangular to polar. All right. So write this down. Number example 1. Convert 4 minus 4 root 3i into polar form. Okay. Is this a coordinate or a number? It's not a coordinate because you don't have commas and parentheses. Obviously, this is a complex number, right? This is the a part, this is the b part, the real part, and the imaginary part, okay? We want to convert it into polar form, okay? So, in order to convert this into polar form, we want to make it look like something like this. R cosine some angle plus I sine some angle, okay? So all I need again is just what? I simply need R and theta. Okay, if I have R, I put it outside the parenthesis. Theta goes in after the sine and cosine. Alright, so let's find R first. R is the absolute value. Okay, it's just like the example we just did. We're going to use the formula square root of a squared plus b squared. Due to the Pythagoreans, we're looking for the length of the hypotenuse. Okay, this is R squared, we root both sides to get this here. What is A? A is the number that comes first, right? A, B, C, D. A comes first, and then B is the one that comes next. Watch this carefully. You're going to have the square root of 4 square plus 4 root 3, negative 4 root 3 square. You notice how the minus goes in the parentheses is being squared. Don't put the minus outside, okay? That's inaccurate. Alright, so let's square this. If I square 4, simply 16, plus, if I square, this square right here gets distributed into these two numbers, the radical and the whole number, right? It's not a whole number, that's an integer. The radical and the integer. So if you square the integer, you get 16 times, if you square the radical, you get or the irrational number, you get 3, because the square of the 3 cancels out. Square and square root are opposite, so they cancel out. So you end up with 16 times 3. That becomes the square root of 16 plus 48. What is 16 plus 48? I wish I knew. Oh, 64. Comes out nicely, which is 8. So there goes the radius. We have one of the answers in the bag. R equals 8. Now what do we need? We need theta. In order to find theta, we're going to use that formula we considered before, which is as a result of TOA, in SOHCAHTOA. We're going to take the inverse tangent of y over x. What is y? What is x? The one that comes first is x. This is also x, right? And this is also y. Alright? Well, inverse tangent of a over b is the same thing. So we're going to take the inverse tangent of the second number, negative 4 root 3, which is also y, or b, divided by the first number. And then when you divide that out, you can reduce this 4 and this 4. This one goes here 1, that goes here 1. And then you have the inverse tangent of negative root 3. Alright? Okay, now we're going to make use of our calculators to do this one. To get my answer in degrees, I'm going to make sure my mode is in degrees. Okay, that's good. So we're going to put this up. We're going to go second function inverse tan of the square root of 3. And then our answer is 60 degrees. Alright? So that's equal 60 degrees. Or, what is 60 degrees in radians? You could cheat and look at your unit circle. 60 degrees is pi over 3, right? Same thing as pi over 3. 60 degrees or pi over 3. When you're doing your classwork today, I would like you to give me your answers in degree form and radian form, okay? So our answer is 8. Our answer in polar form polar form is going to be 8 cosine 60 degrees plus I sine 60 degrees. This is in degree form. Or you can write 8 cosine pi over 3 plus I sine pi over 3. Exactly the same thing, but this is in radians. Alright, so for classwork, I like to see you express the results in these two forms where possible. Alright? Okay, now let's try another example. What if we're going the reverse direction? What if we're going from polar form into rectangular form? What would that look like? That's what we're going to be trying next, okay? Alright. Now write down the following example. Example 2. Convert 3 cosine 4 pi over 3 plus I sine 4 pi over 3 into rectangular form. Okay, into rectangular form. Graph it, and find the absolute value. Okay, we have some extras on this problem. Not just conversion, you have to graph and find the absolute value. So let's do the conversion first. If you look at this problem that we have, right here, 3 cosine 4 pi over 3 plus I sine 4 pi over 3, it's telling us something. It's telling us two things. It's telling us r and theta. It tells us that r is the first number right here, right? That's supposed to be r, right? R is 3, and that theta is, see these two numbers right here? This and this, both of them are theta. Right? That's theta. That's theta. And that means theta is 4 pi over 3. Okay? That's r, that's theta. So we need x and y. This problem is not that difficult. Cosine 4 pi over 3 and sine 4 pi over 3 can tell us what x and y, a third of what x and y are, since 3 is out here. So let's find out what cosine 4 pi over 3 and sine 4 pi over 3 are. If the angles are on the unit circle, you don't need a calculator, you can be exact. But if the angles are not on the unit circle, then you have to use a calculator, okay? So it's 4 pi over 3 on a unit circle, I think it is. Let's see. 4 pi over 3, where are you? Oh, right, there it goes. Negative 1/2 and negative root 3 over 2. Okay? So, 4 pi over 3 on the unit circle is negative 1/2 and negative root 3 over 2. Remember, on the unit circle, the x-coordinate is strictly cosine, and the y-coordinate is strictly sine, right? So what is cosine 4 pi over 3? Let's see. Bring down this 3. Cosine 4 pi over 3 is the x-coordinate here, which is negative 1/2. Okay? Plus, bring down the I, the imaginary. This I keeps the imaginary and the real separate. Okay? Times, what is sine 4 pi over 3? Negative root 3 over 2. Okay? Now, we're going to distribute this 3 out here to both numbers. We're going to distribute it. We're going to triple the real part, and we're going to triple the imaginary part. Alright, that doesn't look good. Anyway, we're going to distribute. So if we distribute, we're going to have negative 3 over 2 plus, if you times minus and minus times plus, let's just make this minus. Minus 3 goes on the outside. 3 root 3 over 2 times I. Okay? So, there you have it. I just switched the I and the root 3. I moved them around. This is a product right there. Okay, so this is standard formula. Let's write the number first before the I comes next. Okay. So uh, this is the polar point. This is the polar point. A rectangle. Okay. All right. So if you want to graph this and find the absolute value, let's to graph it first. We just need to make this into decimal because it's easier to graph decimal. Negative 3/2 is basically negative 1.5, comma. We're gonna graph negative 1.5 for the x, and then for the y, let's see. We're gonna do 3 root 3 divided by 2, 2.6, negative 2.6 for the y. So that's what we're going to be graphing. Okay? So make a coordinate system. Well, we're both negative, so we're going to be in quadrant 3, right? So let's make our quadrant 3 a little bit bigger. All right, so I'm going to go 1, 2, so 1.5 will be in the center. And then I'm going to go 1, 2, 3. So 1.5 is right here. And we're going to go down to 2.6 is somewhere here. Alright, so there goes your answer. There goes the graph of this result right here. Okay, negative 1.5 and negative 2.6. Alright, how about the absolute value? The absolute value is going to be the square root of negative 3 squared plus negative 3 root 3 over 2 squared. Alright, so let's do this. So to do this, we're going to square the radicands first. When we square those two, we're going to get 9 over 4 plus, this becomes 9. Let's square them one by one. 9 times 3 over 4. You notice what happened here? Everything got squared. This one got squared, that got squared, that got squared. Like that, right? So now you're going to have 9 over 4 plus 27 over 4 square root. That's going to become the square root of 9 plus 27 is 36. 36 over 4. Right? And it's going to become 6 over 2. But there are different ways we can do this, right? You can divide this to make it root 9, which is 3. Or you can divide it, whichever way you want to do it. It doesn't make any difference. Anyway, it's 3. So the absolute value is 3. Okay? Alright. Thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure. Now we're going to go ahead and start with the second part of our class. Okay?